Hi everyone. Okay, it's nice to see you again, and of course we would continue our discussion on graphing circular functions. We are through with sine function, cosine function, and tangent function. This time we are to discuss on graphing cotangent functions. Okay, and of course the same with the other first three functions. We have our learning competency, and that is we are to be able to graph cotangent functions showing the amplitude, period, and of course the phase shift. Okay, as we recall the concepts, okay, we have here of course the standard form of the equation of your cotangent. Y equals a cotangent b quantity x plus c plus d, where a stands for the amplitude. Okay, that is significant of course in plotting the points from your division of points. Okay, and then of course your b would be helpful for solving for the period, which is pi over b. And then of course for c is the phase shift, moving horizontally either to the right or to the left. And of course for d for the vertical shift, it's either upward or downward. Okay, let's have here the first function, of course the parent function, which is y equals cotangent of x. We all know that once we rewrite this one, the equivalent value is y equals cosine x over sine x, and that is the reciprocal of tangent. Now, in our denominator, what will happen once our denominator, let's say for example, sine x is equals to 0, what will happen? Yes, automatically our that would show us an undefined. Okay, and but of course in graphing, that will serve as our vertical asymptotes. So here are the values of sine that would make the it equals to 0. Okay, we have here 2 pi, pi, 0, negative pi, and of course negative 2 pi. These are needed for in our graph for the cotangent function. Okay, as we are to show this, of course there you have on the board um, the undefined value. Once this will be a 0 on our denominator, this will be what will happen to them. This will serve as our vertical asymptotes. Okay, so as you notice here, we have four periods showing that to show our graph of the cotangent function. So take a look also of our um, given center of its uh, coordinates. We have, there you have it guys. Okay, so and take a look, we have here the diagram showing the graph of cotangent, okay, per period. Okay, as you observed a while ago in our board, in our graph. Okay, yes, there you have it. Okay, now let's have an example. You are to graph here y equals 2 cotangent 1 half x. Okay, so the same from our previous discussion on sine, cosine, and tangent. Of course, our value of a is 2. That would stand for the amplitude, okay, which is the absolute value of 2. Okay, and then of course our b is 1 half, which is needed for the computation for period, which is pi over b. Okay, and then b is to be substituted with 1 half, and then of course upon substituting it, our period therefore is 2 pi. Okay, so a while ago in our discussion that 2 pi is considered as one of the vertical asymptotes. Okay, so if you would want to show it our diagram, okay, here you have it. Okay, so from 0, 0 also is said to be a part of the vertical asymptote together with 2 pi. Okay, and this is just one part of the period of your cotangent function. Once we divide it into two equal parts, of course the center is pi. Okay, afterwards, once we also divide this pi from 0 is pi over 2, and then pi over 2 plus pi is 3 pi over 2. So these are our needed divisions. Okay, and then afterwards we are to determine also the coordinates applying our amplitude of 2. So you notice here your 2, that means, okay, this is 2 points. Okay, and then of course pi over 2. So our coordinates therefore will be pi over 2 and 2 with this. And then on the other hand, this one is 3 pi over 2 with negative 2. So again, this is useful for us to determine the coordinates of our graph for the cotangent function. So again, remember, after determining the period, determine the division of points, at least 4 equal parts. Then of course with that, it is useful for us, the same true with your tangent function, with what we have discussed from the previous video. Okay, now let's comparing our parent function, which is y equals cotangent x. We have to compare also y equals to cotangent 1 half of x. Then of course y equals to cotangent 1 half quantity x minus 1. This time we have the phase shift. And then of course lastly we have y equals to cotangent 1 half x quantity x minus 1 minus 3, and therefore the negative 3 there is our vertical shift. Okay, so let's show that on our um, graph. Okay, so what would be, okay, let's start with the y equals cotangent of x. Okay, we all know that this is our graph. Okay, you notice that it's just a reverse of our graph of the tangent. Okay, what if we have the value already of our amplitude? Okay, and of course the p. Okay, your b there is 1 half. So y equals to cotangent of 1 half x. You notice there the blue one. Okay, that means that the significance of your 1 half there would stretch the graph. Okay, and then of course your 2 there is of course your 2 points being determined a while ago. Okay, and then this time the third given function is y equals to cotangent 1 half of x minus 1. Okay, and we have the phase shift, which is negative 1. So we have observed from the blue one, negative, once we transpose that one, so it translated by 1 point. So this is now, and of course they are just the same. It was moved 1 unit to the right. Okay, then of course lastly, if we compare y equals to cotangent 1 half of x minus 1 minus 3. Okay, your negative 3 here translated, of course, from our purple one, take a look from our original compared with the blue. Okay, this is our original y equals to cotangent 1 half x compared with this purple. What do you observe? Okay, it translated 3 units. Okay, so 1, 2, 3. There you have. Okay, so downward. Okay, so that's the significance of the phase shift, significance of our amplitude, and of course significance of our phase shift. Okay, so again, it's now what do you call this one, very easy to graph our trigo functions or circular functions. Okay, because we have just repeating these steps and procedures from sine to cosine to tangent. Okay, so as we generalize, okay, we have here, um, you notice, of course, our summary of our discussion, that we need, of course, to um, show, and of course remember the terms from amplitude, the period, which is pi over b, and of course the phase shift, and lastly of course our steps in determining the graph of your cotangent function. Right after determining the period, what will you do is, of course, you need to find 4 equal parts, okay, so, or division of points, and then from there you will work on with your coordinates for you to determine the um, the graph of our cotangent function. Okay, and then of course we need to draw a smooth curve. Then of course by period, you just extend it, you just copy a period of that. Okay, so hoping you have again recall and learn something with what we have discussed today, guys. So thank you for listening, and again, see you in our next video discussion.